Hello and welcome to Isabella's explanation of math things. Today I will be reviewing a problem from Unit 5, which I believe is logarithmic functions. The problem says investigate the equation y equals log base 10x squared. Just a quick reminder that to investigate a function means to find and look over its four faces, which you probably remember are graph, equation, writing, and table. Let's begin by looking at the equation y equals log base 10x squared. You should know that this is a logarithmic function and that a logarithm is an exponent. We have our log and then we have BAP. BAP. Base, answer, and power. So we can rewrite log base 10x squared equals y as 10 to the yth power and 10 to the y power equals x squared. Can you see how we did that? Again, we have the base, answer, and power. Nice and easy. So now that we know our equation, we can begin to make a table of said equation. We can make columns for x and y. I've taken the liberty of selecting 21 digits for us to plug into the equation from -10 to 10. When we graph this log, these numbers will give us a nice sample of data to look at. So now we can begin plugging in values into the logarithmic form of our equation. I'll do a few examples and then you can try this on your own. Let's try -5. -5 squared is 25. This is the part where you each whip out your calculators to use the log function. Calculators automatically do log base 10, so if we input 25 and press the log button, we get about 1.4. So with this equation, when x is -5, y is 1.4. It's that easy. I'll do one more example. Let's try 2. 2 squared is 4. On your calculator, type in 4 and click the log button. You should end up with 0.6. Now that you know how to do these, I'll give you a moment to pause the video and perform these calculations yourself. Alright, welcome back. I hope you paused the video, or else that was kind of awkward. So this is what you should get at the end in order. 2, 1.91, 1.81, 1.69, 1.56, 1.4, 1.2, 0.95, 0.60, undefined, and then all of those same answers again. So let's look at one point here. Why did we get undefined when x equals 0? Well, think about it. 0 squared is 0, but you can't have the log of 0. It just doesn't happen. Logarithm is an exponent. You can't, no, that just, no, okay? If you input this into your calculator, it just says error. It's undefined. So our asymptote, or the line where there are no points, occurs at x equals 0. There are no points on this part of the graph. No. After creating a table, we can begin to graph the equation. First, we'll plot the points we got from our table, like so, and when you're done, the graph should look more or less like this. Notice how none of the points actually touch the line here of x equals 0 or the y-axis. Again, this is our asymptote. Now that we have a graph, table, and equation, we can write about it. Well, we know the asymptote is at x equals 0. We also know that this is a logarithmic equation, which we know from looking at the equation in the beginning of the video. The domain of the graph is -infinity 0 because the graph extends forever in this direction and ends at 0. Remember, we use a parentheses instead of a bracket because the graph doesn't actually include 0, it just ends at 0. Our domain is also 0 positive infinity because the second part of the graph starts at 0. It doesn't include 0, but starts at 0 and goes on forever in the opposite direction. And next we know the range is -infinity, positive infinity because the lines extend forever in this direction, and although they are rising slowly, they will eventually reach positive infinity. Since the rate of growth is so infinitely small, we'll only be at y equals 8 by the time x is equal to 10,000, but we will get to infinity eventually. That's pretty much everything you can say about this equation. It looks like two inverse exponential functions, and the asymptote is at x equals 0. We can now say that we've investigated this equation. Now, I was actually pretty surprised to see how common logarithms are in the real world. There are actually logarithms in psychology, if you can believe it. There's a thing called Hicks' law, which has nothing to do with the South, but Hicks' law states that there is a logarithmic relation I'm so funny. Okay. Which states that there is a logarithmic relation. Why can't I? Thanks a lot, Julia. Okay.
Sorry.
Which states that there is a logarithmic relation between the time individuals. Okay. There's a thing called Hicks' law, which states that there is a logarithmic relation between the time individuals take for choosing an alternative choice and the number of choices that they actually have. There's also Weber-Fechner's law, which proposes a logarithmic relationship between stimulus and sensation. So, like, the actual versus the perceived weight of an item someone is carrying. Finally, there is a thing called Fitt's law, where the time required to rapidly move to a target area is a logarithmic function of the distance to and the size of the object. If you can wrap your mind around that. So yeah, psychology. Weird and stuff. Yeah, seems pretty cool. Alright, I think that's enough math for 6 minutes, I think. 6 minutes and 17 seconds. Roughly 6 minutes. Alright, Isabella, out.